Lascelles. I'm the factory representative for Watts Radiant Heating and Snow Melting. I'm here to describe and to do some owner training on the radiant floor heating, and also in this segment we'll do that, and then the snow melting in the next segment. The purpose of this training is to help them understand the functionality of radiant heating, and also how the manifolds and how the tubing is set up and laid out so that they can easily troubleshoot it and do any repairs or anything that they might need to do. The radiant section itself is on the mechanical pages, page 218 I believe it is, 2.18, where it shows the snow melt and the radiant on the same page. We're right now in the northwest corner of the building in the customer service area. This portion here is radiant heated. Also, behind you there is the north entry. That also has tubing in it, all the way up to about where the Shields entrance sign is. And there's tubing in there, 12 inches on center, half-inch tubing. Laid out in order to create a buffer. What the engineer and the architect were trying to do is to create a heat zone or a buffer zone. If you're familiar with what radiant does, the tubing is in the floor and it's encased in concrete and secured on the insulation below. So what we do is pump water through that tubing to raise the temperature of the slab so that we get an effective surface temperature of about 85 degrees at the surface when it comes in. What that accomplishes is kind of twofold. It creates a buffer zone for the entrance as they come in, and it also, as they come in during the winter, they'll bring water and snow and stuff as it comes in. And what that does is it helps to dry that snow as it comes in and keeps it melted off and keeps that buffer. So as you heat up the slab, you can imagine we get this whole slab up to, say, 85 degrees at the surface. So as the doors open and close on a busy day, Fridays, Saturdays, it's going to be busy. As they come in and out of the building, that radiant heat is going to store there. So on air side, when you have warm air blowing on you and then it stops, you immediately start to feel the cold. What the radiant will do is, as they come in from the cold from the outside, they'll come in, and then as the door shuts, we're creating an ambient buffer area here, about 8 to 10 feet high, so that immediately when the doors close, they'll immediately feel warm again, even though there's no air blowing on them. So that's what we're trying to do with this zone here. And where people are waiting next to the doors in the customer service area, they wanted this area to stay even temperature for people as they're waiting, because a lot of times they're dealing with problems or whatever. Keeps them a little more even-tempered when they have to deal with problems and issues. So right here you'll notice is the manifold. This is the manifold for the entry area. It's kind of hard to see if you can see under there. There's several loops. Each of the loops is 300 feet in length. What we tried to do was to keep all the loops the same length. So in essence it kind of self-balances itself with the flow. You can see on each of the loops there's an indicator, and that designates the flow that's flowing through each of the tubes. They're pretty much the same right now. It may require some balancing because some of the tubes may have some jiggles in them or extra loops, so it creates a little extra friction loss in the pipe, and so we may have to balance a little bit in order to get them all about the same. After we do our little walkthrough here, I've got a demonstration over there. I'll show you how to balance each of the zones. Each of them will be balanced from the top blue actuators you can see on the top, and then these are the flow meters at the bottom. There's a connection here that we'll go over as well when we do the training on the manifold, where each of the tubes is crimped to secure that, to keep the pressure up on the line for what you need. Also, there's a balancing valve at the end of each of these manifolds that we'll go over as well. Let's slide over here to the other side and you get a better, closer look at this manifold. Over behind the wall here is the manifold for the customer service area. Gives you a little better look at the manifold balancing, or what it gives you here is a readout for the supply, which is the hot. Red means hot, blue means cold. The supply and return temperature, what we do is in a 300-foot loop, we should have about a 15 to 20 degree difference between the inlet temperature and the outlet temperature. That means that the heat's going into the slab and then it's radiating into the space that we've got. This will be controlled by a sensor that's in the slab through our automation people, and they try to maintain a slab temperature and supplement that with the air side for what we need to do. Okay, let's go on over here over to the table and we'll show you how these manifolds work. The radiant manifolds are set up in pairs. Each of the circuits has its own indicator on it. On the top of each of these is an Allen connection you can see. Most of the manifolds should have one of these Allen keys. What you do is, it's the same as anything. Right to restrict, left to open, like any type of thing. So if you're trying to balance this and you see one of them maybe off a little bit, you can crank that one open or closed or vice versa in order to try to balance these two flows where they want to be.
What are you calling balanced?
Balance is you want to have this indicator to be the same.
Okay.
Most radiant zones per circuit are going to run about anywhere from 1/3 to 3/4 of a gallon maximum. Most of these should be around 1/2 gallon when they're set and running fully open with a 300-foot loop. Is pretty typical of what we've got. So we'll look and see how the tube was put in. I saw some of the tubing when it was put in, and most of the lengths are pretty even as far as the way they KHI laid those out. So they didn't do a lot of weaving back and forth to get them in. So that should keep our flows pretty balanced. Each of the connections on these, it works with either a gasket like this or an O-ring. As you can see on the end of this, there's an O-ring to seal that up, and a gasket for any of the connections that go on. So on the ends, it can either be the ball valve type that we've got there, or a adapter like this with the indicator. So if you do have to remove those, you need to be careful and examine that gasket. So if it gets torn or sheared in any way, you don't want to lose pressure or leak glycol into the building. So these are readily available at the local suppliers or at our local office, so we can get those for you if you do run into a problem that way. And they just come on the same way. There'll be a vent purge assembly on each one on the end. There may be only one that has the vent purge assembly on the end, and the other may just have an end cap. You only need to really purge one side. So as you open and close valves, you may need to purge the system or purge some air out of it. This is like a regular hose type connection. I think if this comes off, you can actually hook a smaller hose into it, or if you have like a rubber hose or a regular hose, it'll actually push on the end of that if you want to put a hose clamp on it just to make sure. And then you open and close it this way, and it'll allow the fluid to run out, or air in the case that we're doing. So if you do have a leak or you need to isolate a valve, you just close that off here until you see this red thing go all the way to the top, and that indicates no flow. And that valve is isolated, or that loop is isolated. Say someone adds a sign or something later and they hit a piece of tubing, and it creates a leak. You can isolate that valve, keep the rest of your system running till you do your repairs, then you can come back and open that valve up. So you can imagine when you open that up, all the fluid that was in that tube has now become air, so it pushes itself through, and it could go in any of the loops that are on there. So that air will migrate around. It's not scooped up by the air scoop. And so you'd have to purge each one of these loops. So you could start like we did over on that manifold there. You could start at one end and just kind of leave them, turn them all off, open one valve until you hear it running smoothly, and then close that one off, go to the next one in essence until you've got them all done. This would probably take you maybe 5 or 6 minutes to purge all the air out. This one would take 10 or 15 seconds, so depending on how many loops you got. So that's kind of the way that works. The connections are the same. If you ever had to replace a tube or you start to get a leak, the only place it's really going to leak is at that O-ring. You got to be careful as you push those in. You got to push it in, and then you turn the thing on so that you don't try to force it up. You may fold that O-ring over, and then you'll get a leak that it'll kind of drip or ooze along the edge of that. So if that happens, you just want to get a new O-ring and put it on and then push it back in. Don't try to repair it because it's already flat on one side. So just repair it. All the tubes are crimped with a copper crimp ring to secure it on. You can cut these off if you had to repair something in the manifold box, and then you could splice a piece on and then re-crimp it back on the same way. If you do have a leak in the floor, it can be repaired with a field splice, just a splice, coupling on both sides. Crimp that. It's approved to be buried in concrete. I would recommend putting a foil tape or a duct tape around that. It just gives a longer time for the acids in the concrete, less time to penetrate and start getting into the copper or the brass. But we've been splicing for years, and I've never had any that we've had to go back and repair, so works both ways. Okay, I think that's all I've got on this side.
As far as attic stock, should they carry some of those O-rings and such?
Yeah, I would say you may want to have some rings or a splice kit, just in case you have a break, where I think the kits come with maybe 2 or 3 splices in it, and then some rings on it, and then some O-rings and some gaskets, and if you ever have to replace or take a valve off, then you've got those ready for you. So it's a few dollars worth of stock parts in order to maintain that manifolds.
Can you get some of that for us?
I can.
What about warranty?
Warranty, the tubing's warranted for what they call commercial lifetime, which is 25 years against any manufacturer's defect. However, it's not freeze-proof, so if something happens, or it's not drill-proof, so if it freezes and breaks, or someone drills into it, that's not covered under warranty. But if for some reason you have a pipe burst, say the manifold is most likely where it's going to go because you're encased in concrete, all the expansion is going to be at the end. If that does burst, what we do is cut that section of tubing out, give you what you need to repair it, and then we send that back to Watts, and they examine why it burst and what happened with what it burst. If they determine that it is a manufacturer's defect, then they pay for whatever materials were used and whatever labor was caused, and any damage that it may have caused to, say, tile or drywall or anything to that effect. Doesn't happen very often, but it can happen. I've seen it happen a few times, so you should be covered warranty-wise. Okay, we've moved from the customer service area to area D, which is on the kind of the north or the southeast corner of the building. It's another section of entryway where we put radiant floor in to do the same thing that we did at the other end of the building. This one has a few less circuits than the one up there, but it extends a little further out to where the shields it's covered kind of the same way. Just wanted to let whoever's training on this would know where this section is, and the manifolds are the same as the other end, so they'll function the same way.